Hello, I'm Rich Park, and this is a lesson or a discussion, and I want to present how I'm using a program called Scratch in the classroom, and I'm subtitling this presentation Digital Fluency, or Scratch, moving from content consumer to content producer. I'm going to be relying heavily on a paper by Michael Resnick, who is part of the Scratch development team at the Massachusetts Institute of Technology. And there's a picture of the paper I'm looking at here. He has several thoughts in this 2009 paper regarding Scratch that express things better than I can, but I do want to take the time to explain why things work well in my classroom and how I've personalized Scratch to work with my age group. One of the points that Resnick makes in his paper regarding digital fluency, and to me digital fluency is much the same context as talking about content creators versus content consumers, or working at the higher order of Bloom's taxonomy. So he defines digital fluency. I hear the same sorts of terms over and over again. Should mean designing, creating, and remixing, not just browsing, chatting, and interacting. And the vehicle to accomplish these types of goals, in this particular case, it's the Scratch programming language, but really it can be any type of complex learning activity that allows students to manipulate, learn, exercise problem-solving skills, and work with objects to produce an outcome that is relevant to them. So that's the important part. And actually the flip side of Scratch programming is robotics, because without programming we can't have machines that we can manipulate, because software is what manipulates machines. But regarding programming, which I use in my classroom because it's more flexible, because I can't give everybody a robot, here's what Resnick says. Why programming? It has become commonplace to refer to young people as digital natives due to their apparent fluency with digital technologies. Indeed, many young people are very comfortable sending text messages, playing online games, and browsing the web, but that does not really make them fluent with the new technologies. Though they interact with digital media all the time, few are able to create their own games, animations, or simulations. And he mentions here it's as if they can read, but they cannot write, which is a very good observation. How we use the digital technology, it's a powerful technology and it's complex to learn, and we want to reduce that complexity, but we also want to use it meaningfully, not just as a recreational device. The benefit of students taking responsibility for the construction of their own content is really not a new idea. Let's go back to 1902, and I want to quote a paragraph from John Dewey and his book, The Child and the Curriculum. And he talks about content, and he explains it as a map. He says the map is not a substitute for personal experience. The map does not take the place of an actual journey. The logically formulated material of a science or branch of learning, of a study, is no substitute for having the individual experience. That's 1902. Let's move this forward, and I want to quote a bit from a paper called Piaget's Constructivism and Pappert's Constructionism by Edith Ackerman. And she talks about Piaget's constructivism offers a window into what children are interested in and able to achieve at different ages of their development. The theory describes how children's ways of doing and thinking evolve over time, and under which circumstances children are more likely to let go or hold on to their currently held views. In other words, they're learning by doing. Papert, who studied with Piaget, takes this a step further. Essentially, Seymour Papert was the technological disciple of much of what Piaget did, and Ackerman explains Papert in terms of constructivism. And she says Papert's constructivism, in contrast, focuses more on the art of learning, or learning to learn, and on the significance of making things in learning. In other words, Papert, in technology, the way he used it, was to have students construct their own learning devices, and as he would explain it, creating tools to think with, and that was a little bit different. And then in the same spirit, Resnick, in his paper on Scratch and learning in that environment, he views this much in similar ways of Papert, but the Scratch programming language gives us a little more expandability. But he says, in particular, programming supports computational thinking, helping you learn important problem-solving and design strategies such as modularization and iterative design that carry over to non-programming domains. And since programming involves the creation of external representations of your problem-solving processes, programming provides you with an opportunity to reflect on your own thinking and even about thinking itself. So, looking at these quotes, and this is carrying us essentially through from 1902 almost to the present day. These are thoughts that are not new, but what they're discussing here is the development of metacognitive skills, which is such a buzzword today in developing content. So in this presentation, in this lesson, I've got several examples for you to look at regarding Piaget, Papert, Scratch, even a quote from Dewey's book that I was able to take offline. And so enjoy what you see here, and then I will also show you some examples of what I do in the classroom when I use Scratch. Scratch is such a benefit, especially in a resource-constrained, budget-tight environment, because we can get that from MIT, and it does not cost us anything, although it's not without value. So that is a valuable tool. And then also, what Scratch gives me in the classroom is the way to deal with different socioeconomic status students, different ethnicities, different levels of technological awareness and ability. And putting all of these things together, it lets me have a tool to work with large classes to develop problem-solving and metacognitive skills. So enjoy the rest of the presentation, and I hope you find this valuable.